Here's part 2 of this video. So hopefully you've done some of the assignment already and explored graphs of linear inequalities. We see linear inequalities all the time in the real world, even though we don't usually draw graphs of them. But we want to figure out, we have two things we've got going, and we've got limitations, and we want to figure out what's the options available to us. That goes through our minds way more often than you might think. So for example, this is like page 305, number 8. So when you're choosing your word problem to do, don't choose number 8 because you've already done it. Let's just say Mr. C, some random Mr. C, coaches a hockey team of 18 players, and he plans to buy new jerseys and sticks for the team. The supplier sells jerseys for $50 and sticks for $85 each. Mr. C can spend no more than $3,000 in total. How many jerseys and sticks should he buy? So this idea of no more than, that's an inequality. So we can know that we're dealing with inequalities here. All right, first question, what number classification are we talking about? When we're dealing with sticks and jerseys, look on the board, look in your notes back at 6.0. Which number classification? I would suggest that you cannot have part of a jersey or part of a stick, so we're not going to be using decimals. We are going to be using whole numbers. We also know that we can't have a negative amount of sticks or jerseys, so it rules out integers. And we could possibly have 0 of one of them, I suppose, if he really wants to go with a lot of sticks and they just bought jerseys last year. We could use a 0, so we're sticking with the whole number classification. Okay, what are the two variables? So traditionally we would choose x and y. Doesn't have to be an x and a y. We could use j and s, for example. We can look at the story problem and find the two things or two items that we're looking or dealing with. In this case, we can see there's jerseys and sticks, so those are the two variables we're going to choose. And why not? We're going to let j equal the number of jerseys. Why not choose something that makes sense? And we will let, I didn't leave enough room here, let s equal the number of sticks. Okay, I can see that you might be tempted to just write let j equal jerseys and s equal sticks. It's less writing, but I would like your definition of your variables to state exactly what the variable represents. And in this case, it's the number of jerseys and the number of sticks. So try to be specific as you define your variables. Okay, now what is the inequality mentioned in this word problem? So I'm going to grab my highlighter here. Some of you do use highlighter, especially on tests, to pick out the important information in the question. And that's what we're going to do here. It's a great strategy. So we have the idea of 18 players. Is that necessary for us here? I don't think so. We're looking for the number of, I don't think we need that information. We do need to know, because we're looking for the number of jerseys, we need to know how much each jersey costs. And we do need to know how much each stick costs. Because we know that we have to keep our costs less than, no more than $3,000. So it's the money issue here that we're dealing with. So the inequality, we have each jersey is $50. So the jerseys are going to cost $50 multiplied by j, the number of them, 50j. And we're going to add the cost then to the sticks, and they are $85 multiplied by however many sticks we're getting, which is the variable s. We know then our total has to be less than or no more than $3,000. Can it also equal $3,000? Yes, no more than implies it can be equal to $3,000. Okay, so there we have an inequality. And when we looked at the problem, defining an inequality out of it seemed kind of daunting. But when you take it step by step and figure out what we need to keep it less than, then you know that we're dealing with money. And then you can figure out the cost of each. So it is doable if you take it one little step at a time. So what we need to do here is follow the exact steps, and let me show you them. We're going to put the equation we wrote into slope-intercept form and find the m and the b. Then we're going to plot the b and then plot the slope. And then we're going to join those 2 points up with to form our boundary line as either solid or dashed. In this case, it was greater than or equal, less than or equal to, so we're going to be a solid line. After drawing the boundary line, we are going to shade the solution region using the correct color. So if we flip back here, and again you can see that I have given you these steps right here to follow as we're doing this example. Okay, so let's put this into, you can pause it here and do the work on your own and then just check it if you're wanting to test yourself. Let's put this into slope-intercept form. Now, good question here, which variable is going to be our y? It doesn't really matter, but I'm going to move this down a little bit so we can see the x-axis. Let's choose, let's choose our x to be s and our y variable will be j. So we are going to solve for j. We're going to subtract 85s from both sides. Now you can go ahead and drop the dollar symbol, it's up to you. Okay, and then we're going to divide by 50 to get j alone on one side. And so our final equation or inequality in slope-intercept form will be negative 17 over 10s. You'll notice I reduced that. I divided both the numerator and the denominator by 5. Plus 60. And again, I've done that division there, 3,000 divided by 50. Okay, let's look here now and plot these points. So our m, our slope in this case, is going to be negative 17/10, and our b is going to be 60. So let's think of a logical labeling of the axes for j. We need to go up to 60 for sure. I'm going to maybe count by tens. 10, 20, 30, 40, 50, and 60. And we'll label the x-axis exactly the same. You can pause and do that. Okay, you've done this several times now, so go ahead and draw that line, and it's going to be a solid line. We've got a y-intercept of 60, and now slope, you can count 17 down and 10 over. Okay, now I've done that. Now you'll see when you count 17 down, we had to estimate a bit. What I want to do is know exactly, so it's not really great to estimate. So let's see what our value would be if I put a 0 in for y. I want to know how many sticks I could buy if I bought no jerseys. So that original question's up there in blue. I'm going to buy no jerseys, which means I'm going to put a 0 in for the y coordinate, or our j. And I want to see here what the value would be on that x-axis. So that'll be 0. Oops, I forgot the variable s, my mistake. This is 0, that's not there. I'm going to divide both sides by 85. When I do that, I get s is less than or equal to 35.3. Okay, so I do have it. You can see here that maybe my line, I could move it just a little bit this way. 35.3, 35 is right there, so maybe that line there would be a little more accurate. Again, we're just going to do our best to draw an accurate line. And this is a good way to check just to see what this 0 would be right there. Okay, so now our last step, step number 6, is shade the solution region as continuous or discrete. So we've already decided this, we're dealing with whole numbers, so it's going to be discrete, meaning that I could choose any combination less than this boundary line that are whole numbers. Now, when I put dots here, I'm only putting dots on buying 5 or 10. Remember, this line is 5, this line's 10, 15. So really, there would be more dots than we're drawing, because any whole numbers, but these are good. This is a good estimate. And we can also have dots right on this 0. Okay, this dot here looks like it might be part of the solution as well. Yeah, anything on the boundary line also works. So, what does this mean? The whole point of this was to find possible combinations of jerseys and sticks. So, this means that I could buy, for example, this ordered pair would be 5 sticks and 45 jerseys. Or this dot here means 10 sticks and 5 jerseys. Everything in this solution region, when we find the combination, is going to cost less than $3,000. This one here, it appears like it's in the solution region. That would be 20 sticks and 25 jerseys. We could also buy just a whack load of jerseys. We could buy 0 sticks and 60 jerseys. Here, that point was inside, was 0 and 35. Let's close a little bit this way. That would be buying all sticks and no jerseys. So usually these type of word problems will ask you when you're done graphing, give 2 possible solutions. And so you will have to say 2 solutions here would be 20 sticks and 25 jerseys. Or any possible combination from inside the solution region. All right, flip the page. Here we're talking, or just exploring, when the graphed line is completely vertical. There's no y. And another of those examples, or another option would be having no x, and the line would be completely horizontal. And you'll get an experiment with that a bit in your assignment. Maybe you already have. Here is your assignment. If you flip the page, you're going to have a review of those key ideas straight from your textbook. And now you've already done in your assignment these questions, and now I would like you to choose at least one story problem. Number 7 is a good example. Okay, good luck.